Okay, so now my inverse exists. When I talk about an inverse, we know that the domains and ranges switch. So when I look at my inverse function, the domains and ranges switch. So what is the domain of, we call this to the -1. That's called the inverse of the sine, or the inverse sine function. The domain will now be -1 to 1. Because the domains and ranges of inverses switch. So what will the range of the inverse sine function be? -π/2 to π/2. Good. Okay, so what do we know about inverses? What do we know? Well, we know that everywhere the graph is increasing and concave up, the inverse will be increasing but concave down. Everywhere the graph was concave down, the inverse will be concave up. So I'm going to take these values of -π/2, okay. So if I say to you, the inverse, what does it look like? Well, now on the x-axis we have -1. So if I plug in the inverse sine of -1, what are we really saying? Well, where is the sine value -1? Look at your unit circle. Where is the sine value -1? 3π/2, but that's not within the range, is it? So what's another name for 3π/2? Π/2 means I started here and I went in the counterclockwise direction. What's another name if I start here and go in the clockwise direction? -π/2. So what angle has a sine value of -1? -π/2. So that value would be right there. Let's look at 0. What? So if I say the inverse, oh boy. If I say this is -π/2. If I say the inverse sine of 0, what angle has a sine value of 0? 0. So that's right here. And the last one we'll do is, what angle has a sine value of 1? π/2. That's up here at π/2. And that's up here. And so now look. You see from here, it was increasing but concave up. The inverse will be increasing but concave, increasing but concave down. Do you see over here how you were increasing and concave down? The inverse over that same interval will be increasing but concave up. And this is what the graph of the inverse sine of x looks like. Kind of the same idea, except everywhere the sine was increasing and concave up, the inverse sine is increasing but concave down. So the concavity changes. Another name for inverse sines are arc sines. Where do they get the word arc from? Well, if you look over here, how did you do this? You said, what is the inverse sine of -1? What you ask yourself is, what angle has a sine value of -1? You do it again and you're going downstairs and you can talk to Munoz. You ask yourself, what angle has a sine value of -1? So in other words, you're saying, where did you turn your circle to till you had a sine value of -1? How far did you turn your circle? What piece did you turn your circle to? And a piece of a circle is called an arc, and that's where the arc comes from. most textbooks and calculators, should I say most calculators are using the inverse notation. A lot of textbooks like arc, but they mean the same thing. Arc sine of x is exactly the same as the inverse sine of x. Okay? The exact same thing. So when I look at this, if you look at the sine function, to put it all together, the domain of the sine function was negative pi over 2 to pi over 2, and the range was negative 1 to 1. Were you knocking? I'm sorry. Okay. She's giving it to you right now? No, she's out taking a test. She was missing, so she's somewhere down this hall taking a test.
Just you.
And tell her to do what with it? Okay. The domain of the inverse is negative 1 to 1, and the range is negative pi over 2 to pi over 2. So if you look at the unit circle, the inverse sign goes from negative pi over 2 to pi over 2, and I'm going to put closed circles there so you know it's part of that interval. So I can only look on the right half of my circle, quadrant 1 and quadrant 4. So if I'm going to do problems with this, where's our distance? Is this it? The lane? So look, if I say to you, the inverse sine of negative radical 2 over 2 equals what? What I'm really asking you is, what angle has a sine value of negative radical 2 over 2? So if I go to my unit circle, I know that the sine values happen in quadrant 3 and in quadrant...
First one is at the...
Not in the first one. 3 and 4. So what are the sine values? What are the sine angles? What are the sine angles in quadrant 3? What is the angle in quadrant 3 that has a sine value of negative radical 2 over 2?
5 pi.
Yes, 5 pi over 4. And what is the angle in quadrant 4 that has a sine value of negative radical 2 over 2? 7 pi over 4. Okay, but if you remember, the domain is from negative pi over 2 to pi over 2. So quadrant 3 is not even on the right side of the circle, is it? So I could get rid of that angle. This angle is on the right side of the circle. However, when you look at your number line, here's negative pi over 2, pi over 2, pi, 3 pi over 2, and 2 pi. 7 pi over 4 is right here. But I'm only allowed to go from here to here. So 7 pi over 4 is not within that domain, is it? Is there another angle I can call 7 pi over 4? Is there another name? I can call it negative. Instead of 7 pi over 4 means that I started at 0 and I rotated all the way around in the counterclockwise direction. And that gives me 7 pi over 4. But as Aurelius was saying, that if I start here and I rotate in the clockwise direction, 7 pi over 4 is really the same as negative pi over 4, and that is within the legitimate domain. So my answer here is negative pi over 4. My answer is negative pi over 4. So I need to understand what the domain of the sine function is so I can look at what the range of the inverse sine will be. And 7 pi over 4 is not in the range for the values of the inverse sine, so therefore I need to rename it by spinning in the clockwise direction as opposed to spinning in the counterclockwise direction, and there we'll get the proper angle. And it all starts back here when we said, oh, it was not a one-to-one function, and we restricted the domain to negative pi over 2 to pi over 2. So that means that's the domain of the sine function. Therefore, the range or the answers of the inverse sine need to fall within that interval. And 7 pi over 4 is not in that interval, but negative pi over 4 is. You get the idea? Yeah? You get the idea? And so that's what we're doing. You do one more, and then we'll do the cosine, because it's so much fun. So if I said the inverse sine of negative a half, what is that? I draw the unit circle every time, and I don't draw the whole circle, but I draw enough of it so I can see what's going on. So where are the sine values negative? Not the second quadrant. In quadrant 3 and 4. So what is the angle in quadrant 3 that has a sine value of negative a half? 7 pi over 6. Good. And what is the angle in quadrant 4 that has a sine value of negative a half? 11 pi over 6. Well, we know the 7 pi over 6, that's not even on the correct side of the circle. We're looking for either quadrant 1 or quadrant 4. But the problem with 11 pi over 6, it's the right angle or in the right position, it's just not the right name. And so instead of spinning in the counterclockwise direction 11 pi over 6, can't we spin in the clockwise direction and call this negative pi over 6? And that becomes our answer. So they're not terrible, but you got to know the domains and ranges. Yes?
It has to be in the first and
Fourth for the sine.
for sine.
Because we originally limited the domain of the sine, hold on, to be negative pi over 2 to pi over 2.
Okay.
And what we know about inverses is that domains and ranges always switch. So if the domain of the sine is negative pi over 2 to pi over 2, then the range of the inverse sine will be those same values, meaning you need to find an answer to the inverse sine questions that are between negative pi over 2 and pi over 2.
It's going to be different from cosine. Right?
Yes, cosine's actually a little easier because we don't have to rename anything.
It goes from pi.
0 to pi. Because it's easier, you'll see. You got the sine. I think the sine is one of the harder ones because I got that renaming game, you know? So let's look at the cosine curve. Okay. Inverse cosine. So it starts off with the cosine. Let's graph the cosine curve. So to graph the cosine curve, it looks pretty much like that. My question to you is, this is y equals the cosine of x. And the domain here is, of the cosine of x, is the same as the domain for the sine, which was all real numbers, correct? What is the range for the cosine of x? Same idea, negative 1 to 1. Okay, is the cosine a 1 to 1 function? No, it's not 1 to 1. So I need to limit it, the domain. And when you limit the domain, the only rule is that you can't change the range. So where could you limit that domain so you still have a range of negative 1 to what? 0 to pi. So we're going to say this domain is not negative infinity to infinity anymore. It's going to be 0 to pi. So therefore this now is what the cosine graph looks like. Are you with me? So you see how it's decreasing? The inverse will still be decreasing. But you see how from 0 to pi over 2 it's concave down? So that first part will be concave up. So let's graph the inverse of the cosine. So we want to graph y equals the inverse of the cosine. And on the x-axis, we're going to go from -1 to 1. And on the y-axis, we're going to go from 0 to pi. Does that make sense? Because we know the inverse cosine, the domain of the inverse cosine here is -1 to 1, and the range is 0 to pi. So let's do a couple. Let's start out. What is the inverse cosine of -1? What angle has a cosine value of -1? No. Pi. So this is -1 pi, correct? Let's talk about 0. What angle has a cosine value of 0? 0. So that's right there. And moving this just a little out. Uh-huh. 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 And, oh, that's +1, sorry. And what angle has a cosine value of 1? Oh, this one's pi over 2. Thank you. I could play it off that I knew that. I knew that. Yes. And what angle has a cosine value of 1? That one's 0. Okay, now look. It's still going to be decreasing, isn't it? Just like we said, the inverse doesn't change whether it's decreasing or increasing. Do you see how it's concave down in that first interval from 0 to pi over 2? So therefore over here, we're going to be concave up. And you see over here how it's concave up from pi over 2 to pi? So this piece will be concave down. And there's the inverse cosine curve. I'm not going to really ask you to graph the inverse, but you need to know the domains and the ranges. So if you look at your unit circle again, we are looking from 0 to pi. So you're looking at the top half of the circle. Our answers must lie in quadrant 1 or in quadrant 2. So these are actually a lot easier. So if I come over here and I say the inverse cosine of a half. So what angles have cosine values of a half? Pi over 3, and that would be this answer. How about this? The inverse cosine of -1/2. -1/2. What angle has a cosine value of -1/2? 2 pi over 3. So you don't really have to rename them as you did with the sine curve. Did you have a question? Yeah.
So which quadrant is it?
1 and 2. 1 and 2. They're really, the cosine are not bad at all. And I don't know if your book does the reciprocal functions, but we're just going to stick with the inverse sine, the inverse cosine, and the inverse tangent. Thank you.
That's going to be on the next test?
Exactly, luckily. Okay, so we get this. All right, and so now let's do the last one, and then we can look at problems and see what's going on. Let's look at the tangent function. The tangent function goes from -pi over 2 to pi over 2. And it looks like this. Is the tangent function 1 to 1? Yes. What is the domain of the tangent function? But pi over 2 and -pi over 2 are not part of the interval, are they? So notice the difference. There's parentheses here. And what is the range of the tangent function? All real numbers, -∞ to infinity. So now let's look at the inverse tangent. Inverse tangent. Y is equal to the inverse tangent of x. What would be its domain? No, the domains and ranges switch. So it would be all real numbers. It would be negative infinity to infinity. What would the range be? Notice the difference between the inverse tangent and the inverse sine.
One's bottom half, the other.
The range for the inverse sine is negative pi over 2 is less than or equal to y is less than or equal to pi over 2. Do you get that? There's an equal to part where negative pi over 2 and pi over 2 are part of the interval, where over here the inverse tangent, this says negative pi over 2 is less than y is less than pi over 2. They are not part of the interval there. If you remember inequalities, these less thans would have open circles. The less than or equal to would have the closed circle. You remember the difference? Okay. So what does this graph look like? Well, everything's going to switch. Instead of having vertical asymptotes, we'll now have horizontal asymptotes. So we'll have an horizontal asymptote at pi over 2. And we'll have another one at negative pi over 2. Okay, look at the graph. See how it's concave down and increasing? Over here, it's going to be concave up and increasing, and then it will be concave down and increasing. So there is the inverse tangent. Woo-hoo! So, if I said to you, the inverse tangent of negative 1, where is that? Where is the tangent negative 1?
Second quadrant.
Second quadrant and not third quadrant. Fourth quadrant. And what is the value?
Pi. Oh, it will be square root 2.
Yes, but what is the angle, should I say?
Oh, pi.
3 pi
Oh,
over
3
4.
3 pi.
And 7.
7 pi over 4. It's 3 pi over 4, which is out of range, right? And 7 pi over 4, which is in the right quadrant. Look at what we're saying here.
Oh, okay.
Right? It's 3 pi over 4 here and 7 pi over 4 here. But aren't we just looking from there to there? Quadrant 1 and 4. So 3 pi over 4 doesn't work. But it's 7 pi over 4 between negative pi over 2 and pi over 2? No, so we got to rename it. What do we rename it as?
Negative pi.
Negative pi over 4, just like you did with the cosine, with the sine curve. And there you have it. I'm going to give you 3 problems. You ready? The first one. The inverse sine of negative 2. What does that one equal? The inverse cosine of negative 2, what does that equal? And here, the inverse tangent of negative 2. Okay, the first two you do not. What about the inverse sine? You were asking yourself, what angle has a sine value of negative 2? Go back to the original sine. Go all the way back to the original sine.
To negative 2.
Okay. The range of any sine value is
Y.
negative 1 to. So there is no sine value. There's no angle that has a sine value greater than 1 or less than negative 1. I don't care what angle it is. The sine will always be between negative 1 and 1. So is it possible to have an angle that has a sine value of negative 2? No. So this is undefined because it's a domain error. It's out of domain. This is a domain error, and therefore there is undefined. Isn't that true for the cosine as well? Doesn't the cosine also range from -1 to 1? Hi.
Jerry? Okay, tomorrow, you wanted the students to move change, so you have to dress
Most
up.
changed.
So you have to dress up tomorrow.
What's he going to dress out like?
I'll take your picture.
Okay. You understand that the sine and the cosine range between -1 to 1. Therefore, the inverse sine, you can only have in these parentheses values that are -1 to 1. The domain of the inverse sine and of the inverse cosine, the range for the inverse cosine is -1 to, that's the cosine, inverse, where is it? Here. The domain of the inverse cosine is -1 to 1 because the range of the cosine is -1 to 1. The domain of the inverse sine, the domain of the inverse sine is -1 to 1 because the range is -1 to 1. What does this mean? All putting it to boil it down, it means you have no angles that have sine values or cosine values that are greater than 1 or less than -1. So when you come back here, these numbers in the parentheses must be no bigger than 1 and no smaller than -1. If they are, you can't do it. You will get a domain error. But what about the tangent? Can you have an angle that has a tangent value of -2? Yes, because the tangent ranges from -infinity to, therefore the inverse tangent's domain values are from -infinity to infinity. Is it something you can do without a calculator? No, it's not a unit circle angle. So I'd have to go to my calculator. And I would have to say 2 negative inverse tangent, and I get -63 point, I look like a comma, -63.43 degrees. So this is approximately 63 degrees. Which is not a unit circle angle, but it can be done. If you try and do the others, if you come over here and say 2 negative inverse sine or cosine, you get invalid input for function on this calculator. Other calculators might say domain error. Other calculators might just put error, but it can't be done, and that's the bottom line. So you would say it is undefined. Do you understand? And so that's the inverse. They're not that difficult. They're a little more awkward than the regular ones, than the normal functions, but they're not terrible. They're not terrible. They're not terrible. They're not terrible. We mean they're terrible. You ready? Okay. What happens when you do the inverse of an inverse? You go back to the original, right? So look at here. I come in this morning, and the lights look like this, right? The inverse of that is flicking them on. Before I leave this afternoon, what am I going to do? And aren't I back where I started? Does that make sense?
So you're saying is that we're going to go from, they're going to give us the inverse and we're going to have to go back.
Sort of. Kind of. Not exactly. Let's look at this. Let's look at numbers we know. How about that? Was that good? So let's say, what is the inverse sine of the sine of pi over 6? I'm telling you that answer is pi over 6. There's no work. But if you don't believe me,
Oh, yeah.
if you don't believe me, let's do the problems. Don't you work inside the parentheses first? So basically I'm saying, what is the sine of pi over 6? So that's a half. So this is the inverse sine of a half. What that says is, what angle has a sine value of a half? Pi over 6 or 7 pi over 6, but 7 pi over 6 is out of range So therefore, our answer is pi over 6, and we end up where we start. So in other words, the inverse of the inverse cancels each other out. So if I said to you, the sine of the inverse sine of, they use an angle that is not in the unit circle.
Inverse?
Sorry. It's the other way around. The inverse of the sine of 3 pi over 8. What is that? Trace pi over 8. Trace pi over 8. How do you say pi?
I know.
Pi is pi?
No, I don't know. I'm going to
P? P? PP. What about this one? You want to say that, don't you?
Negative?
But I want you to be very, very careful. Because let's go back to my unit circle.
Oh, it's not.
Let's go back to my unit circle. We are looking from 0 to pi over 2, and from negative pi over 2 back up to 0, correct? So I don't know exactly the measure of 5 pi over 8. But if I look at this and I change this to eighths, isn't that 4 pi over 8? So therefore, isn't 5 pi over 8 here? Correct? And that angle doesn't work, does it? So how could I get another angle in this quadrant that does work? Well, look at this for a second. Let's look at the circle one more time. Let's look at angles we know. Pi over 6. That's radical 3 over 2, comma, half, isn't it? Isn't there another angle in quadrant 2 that has a sine value of a half? What is that angle? 5 pi over 6 is negative radical 3 over 2 and a half. Correct? And what is the relationship between 5 pi over 6 and pi over 6? Aren't they complements of each other? Really, no, they're supplements. Sorry, aren't they supplements of each other? Pi over 6, 5 pi over 6 is pi, which is a supplement. So, what angle has the same exact sine value as 5 pi over 8? In other words, what is the supplement of 5 pi over 8? 5 pi over 8 plus pi over 8 is 6 pi over 8. I needed to get the pi because that's 180 degrees. 3 pi over 8, 3 pi over 8 would be in the first quadrant, and so this is the angle I'd be looking for, 3 pi over 8, and that is the answer to this question. That one doesn't work, so we're going to call it 3 pi over 8 because 3 pi over 8 is in the right place, and it has the exact same sine value as 5 pi over 8, except that one was in the wrong quadrant. So you have to be careful. The rules still hold that you've got to be between negative pi over 2 and positive pi over 2. And 5 pi over 8 is not. But we know because that's a second quadrant angle, there's another angle in quadrant 1, namely its supplement that also has it. So how do we do it? We could take pi minus our angle of 5 pi over 8, and that will give us the angle of 3 pi over 8 to answer our question. Supplements, you're just subtracting it from 180 or subtracting it from pi. So you still have to be between negative pi over 2 and positive pi over 2. So you need to know the domains and ranges to do these inverse functions. Okay, you do these two. I'm leaving these for you. The sine of the inverse sine of 0.5. What is that equal? And then the sine of the inverse sine of 1.8. Do those. Take 2 seconds. Go! Go! So, I mean, I like that. I can actually do these problems. What about the second one? What's the story, Giancarlo? It's out of range, isn't it? Actually, it's out of domain. So this is the empty stuff. Because 1.8, there is no angle that has a sine value of 1.8. It's out of domain. These are easy. If I can do them, anyone can do them. You know what I'm saying? You feel my drift? All right. Find the inverse function. Nice. Here we go. Now it gets a little squirrely. Okay, so I want to find f inverse of x. I want to find the range of f. And I want to find the domain of f inverse of x. So let's start. How would I find the inverse? It's a 3-step process. We change f of x to y, just like we did when we found other inverses. You switch the x's and the y's, so I now get x equals 2 sine of y minus 1. And now I solve for y. So what would I do to solve for y? Add 1, so I get x plus 1 is equal to 2 sine of y. I want to get rid of the 2, so what do? Divide by 2, so I get x plus 1 over 2 is equal to the sine of y. How do I get rid of a sine? You inverse the sign. Just like how do you get rid of multiplication? You do the inverse of multiplication, which is division. So we are going to have the inverse sine of x plus 1 over 2 is equal to y. And we're done, except we want to write it as a function. So now we're going to go back and replace our y with that funny symbol, f inverse of x. So coming up over here, we have the inverse sine of x plus 1 over 2 is equal to f inverse of x. And that is the inverse function. It asks me, what is the range of f of x? Well, if this was just the sine curve, the range would be -1 to 1. But what does this do? Moves it down. So if I look at this, just so you can see, if I had f of x equals 2 sine of x minus 1, remember how we graphed? This moves it down 1, so there's 0. So the new intercepts will be at -1. What does the 2 tell me? I will find my maximum values 2 units above -1 or 1, and I will find my minimum values 2 units below -1 at -3, and my graph will range from -3 to +1. So that is the where it go? Where'd it go? So the range is from -3 to 1. What is the domain of the inverse? The range, which would be? Exactly. And we've answered the question. That is good stuff. So,
You got 3.
I didn't get 3, I got -3.
Okay.
Okay, one more time. If I want to graph this, you remember how we graph? I came over here and I said this -1 pushes the entire graph down 1. So all the intercepts are now on this new x, this new horizontal line, x equals negative, y equals -1. Sorry, you see that? This is a vertical shift, pushes the graph down 1. So the intercepts, instead of being at 0, are now at y equals -1. The amplitude, what does that tell me? Well, the amplitude is the distance from your horizontal axis to the max and from your horizontal axis to the min. So what is it telling me? I will find my maximum values 2 units above -1, which is at 1, and I will find my minimum values 2 units below -1, which is -3, and the y values, these are the range values of f of x. Well, we know in inverses, the ranges and the domains switch. So once I get the range of the inverse, isn't that once I get the range of the original function, isn't that the domain of the range? And there's how we did the problem. I think the hardest part is finding the inverse and then understanding what the range is. And then once we're there, the rest of this piece of cake.
Is this recording?
It is recorded. You won't see me dance though, but you'll hear everything else. I can do that too. Can you do this? Oh, so you won't have that recessive trick. It's a dominant trait to do that. You're just not as good as the rest of us.
My mom said she taught herself to do it. What?
You cannot do that. Oh, they asked me, no, I forgot one more. What is the range of f inverse of x? The range of the inverse will be the same as the domain of the original function. What was the domain of the original function?
Negative pi.
So it's -pi/2 to pi/2. I forgot that piece. Okay? Yeah, go fix it. Is it broken?
No, it's in the back of my eye.
It's broken? It's in the back of your eyes? As opposed to the front of your eye? Okay, well, I want you to solve this equation. 3 times the inverse sine of x equals pi. I want to isolate the inverse sine. So what would you do to isolate the trig function? Divide by 3. So I get the inverse sine of x is equal to pi/3. How do you do that? You got to get rid of the inverse sine. How do you get rid of the inverse sine? Sine both sides. So we're going to say the sine of the inverse sine of x is equal to the sine of pi/3. Well, what do you know about the inverse and the function? They cancel each other out. What am I left with over here?
X.
X. And what is the sine of pi/3? That too. Square root of 3/2, and there's your answer. I think these are easy. Got a headache? Face killing us. Okay?
Mine what? Say no, I got that before.
You do? All right. Okay, let's do the next section. It's a little, it's not hard. You need to draw a triangle, though. And you need to get the triangle in the proper quadrant, otherwise things are going to be wrong. You'll get the wrong side, okay?
Keep practicing 10%. Gives me triangles.
Triangle. Okay, it says find the exact value. You do know the difference between an exact value and approximate value. Anytime you put pi in the answer, that's an exact value. You change pi to 3.14, that's an approximate value. So we want to find the exact values. So you're going to leave square roots, you're going to leave things, you're going to rationalize the denominators and all of that good garbage.
The inverse trigonometric functions.
Continued. I want to find the exact value. So we know we work with the inner parentheses. So what I'm going to start off with 1. The inverse tangent of a half is equal to x. If that's true, isn't this true that the tangent of x is equal to a half? Isn't that true? Right? Okay, and that's what I need to do. And so what we want to do is we are going to assume, I know it's a bad assumption, but we're going to assume that our x is positive here. And so you know the inverse tangent is from negative pi over 2 to pi over 2, correct? And since this is positive, what quadrant will this angle be in? 1. So we're going to come over here and we're going to draw our triangle in quadrant 1. Theta is always between the x-axis and that terminal side or the hypotenuse. What is the ratio for the tangent?
Sine over cosine.
Sine over cosine, or in other words, opposite over adjacent. You need to find the hypotenuse. 100, right? 100's the lane, right? Okay, I don't know what you're supposed to do with it. It came looking for you. It said sine. I don't know if you got it. All right, well then maybe that's just for you. That's what she was trying to tell me. What? Okay, problems away. So you should tell somebody. Okay, and one more thing. If this is what the hell, you see, yeah, it's going to be wrong on your diploma, and that would suck. Your mom showed the birth certificate. She might have to do it again, or at least send it with you. Because the last thing you want is your diploma to be wrong, and you got to remember who you're dealing with. Just take that. Her name is wrong.
But how wrong?
Not that wrong, I guess, but wrong. You want your diploma to be right. Okay, so now. Okay, so what do we get? C is equal to the square root of 5. Are you with me? Okay, so the second thing is, I guess this is actually, I'll call this.
Thank you. Thank you all.
So organized.
Okay, I want what's inside the parentheses to be theta. So now you found the tangent of x is equal to a half, correct? You found the missing side. So now the second piece is, it's now the sine of, well, you let theta be the tangent of, the inverse tangent of a half be theta. So everywhere I see the inverse tangent of a half, I'm going to replace it with that theta. Now I go back to my triangle, and what is the sine of theta? It is opposite over hypotenuse. What is the opposite to this theta? 1 over the square root of 5. When we rationalize it, So we get that the sine of theta is square root of 5 over 5, and that's my answer. So it starts off here, really, saying take what's inside the parentheses, the inverse tangent of a half, and let that be your theta. Then come down and draw your triangle in the proper quadrant. Find the missing side. Once you find the missing side of your triangle, come back and say the sine of replacing what's inside the parentheses with theta. You want to find what the sine of theta is based on that triangle, and that value is the square root of 5 over 5. Questions? Questions? Okay, let's do another peanut butter sandwich cookie. Oh, stop. Stop huffing and puffing. Stop huffing and puffing. Okay. So it starts off, 1. Let the inverse sine of negative 1/3 be theta. 2. Isn't it true that if the inverse sine of negative 1/3 equals theta, then the sine of theta equals negative 1/3? Isn't that true?
Yeah.
And so I always start there, and then I'm going to go to my triangle.
Is the triangle in the same place as it was for the 10?
Why not?
It's
The-
not the same.
The sine is now negative. What two quadrants have negative sine values? 3 and 4, but the inverse sine is only defined in 1 and 4, so this is a quadrant 4 angle. Does that make sense? The sine is negative in quadrant 3 and in quadrant 4, but the inverse sine, isn't it only defined from here to here? Right, so it's only defined in quadrant 1 and 4, so it can't be a quadrant 3 angle, it's got to be a quadrant 4 angle, so I want to draw the triangle in the proper quadrant. Theta is always the angle between the x-axis and the hypotenuse. Put the phone away. What is the ratio of the sine? Opposite, and that's this vertical side, that would be negative 1. Isn't the y value negative, or the sine value negative in quadrant 4? And over what? Hypotenuse, which is 3, and I need to find x. Go ahead, find x for me. How do you find x? Pythagorean theorem. That guy is all that and then some. You all right, Christine? It's a lot? It's not that much.
No, the first one's not odd to this.
I think this is easier than the first. Every problem is going to be these same 3 or 4 steps, every one. So they're not terrible.
Square root of 8.
Is it square root of 8? Okay, but remember, what do we know about the square root of 8? We really want to break that up. How do we break up the square root of 8? 2 square root of 2. And because it's in quadrant 4, it is positive, correct? Yeah, okay, so we're going to leave it there. So now I come back, and the last step is to go the cosine of theta, because didn't you let the inverse sine of negative 1/3 be theta? So everywhere I see the inverse sine of negative 1/3, I now replace it with theta. And so what is the cosine of theta in this triangle? Well, it's 2 radical 2 over 3, and I would want that answer. Questions?
Have to simplify.
You should simplify, yeah.
You should?
You should.
Do I have to?
Well, yes, but I mean, no multiple choice test would have square root of 8. No answer in the back of the book would have square root of 8. And so we should do what they did. Questions? We've covered a lot of material.
Yep.
I don't think it's that hard. I think what makes it hard is the idea of you don't know the unit circle, you don't know what the sine and the cosine and the tangent look like, and now I'm talking about those inverses. Are you all right, Zoe? Don't be mad. Be glad. Just be glad, Zoe. Be glad.
Is that it?
Oh, there's 4.
Could I make 14?
But there's, but wait. You haven't seen those commercials?
No.
I got another. Come on.
No, man. Don't work it up here.
Did he spit?
Yeah. No. So like, it'll be like, it'll be connected to be.
Dude, I didn't touch it, so it's like, flying again.
Because you have to put this, go down here, I'll
You know how to do that? I guess I do now. Do you or don't you?
I guess, yeah.
Don't play games with me, man.
I'm playing games.
Look, here's how I do it. I know.
The tree, 4, 2, and then 4 goes also, 2, 2. And
Okay,
then,
if you're looking for perfect squares, how many things together make a perfect square? 2, correct? So I could rewrite this as 2 squared times 2. And then if you take the square root of 2 squared times 2, isn't that a perfect square? The square root of 2 squared is 2. And that's the way I do them. I know what 8 is, though. But if I don't know it, I make a factor tree, and if I'm looking for perfect squares, I just hook up pairs. And then I rewrite it in its prime factorization under the radical, and things work out real nice. And then, I mean, it works. Even what's her name could do it, Danielle. And if she could do it, anyone can do it, trust me. Okay, let's look at this. Now, I said we weren't going to deal with these. Well, we're not going to graph them, but you need to know how to deal with this. So the cosecant. What do you know about the cosecant? Well, I'm going to say the cosecant of the inverse cosecant of 2 is equal to theta. So therefore, what I'm really saying here is that the cosecant of theta is equal to 2. But I don't think about the cosecant. I think of the reciprocal. So the reciprocal of the cosecant is the sine. So therefore, the sine of theta must be a half. So where is the sine of theta a half? Pi over 6 and 5 pi over 6. But 5 pi over 6 is not defined in the region. So the answer is pi over 6. So we do this the same way.
Yeah.
Follow the syllabus, 8.1 and 8.2. Fine. I will check it on Friday.
What? Check what?
The whole-
Oh, instead of everything.
Follow the syllabus, do the homework, let's do the odd problems, because it's a lot of them there. Right? I don't know. You don't have the syllabus? Do you have the syllabus? So you can make me go find it.
I have it in my.
Can you find it and then just tell us?
You know,